Alright, in this video we are going to showcase some features of Magnolia for Blender. First thing you want to do, of course, is to install the add-on. You go to Edit, Preferences, and Add-ons installed, and you double click the zip and you will have it here. To run the add-on is a menu, so Ctrl W is the default shortcut for the menu. You can go to Key Maps and search for Magnolia, and you can modify the shortcut of this menu if you want. You have one shortcut for the 3D view, so the typical view where you edit your models, and another menu for the UV editor. The first mini feature that I'm going to showcase is Report Bug or feature, which is used mostly, as I've said, either to report a bug or an issue that you have, or to request a feature to be added to the add-on. So if you choose bring up the menu with Ctrl W and you click it, it will bring up your mail client, and it's going to automatically set up the mail with some information about what version of Blender are you using, what platform, and what version of the add-on, as well as the subject and the recipient, which is me, at simonsanchez.art@gmail.com. As an alternative, you can manually send me an email if you find any issues with the add-on, or you can contact me from Blender Market if you bought the add-on there. So in case you found a bug, you just simply type here the description of the bug, and you send me the email. On the other hand, if you want to request a feature, if you hover the button, you will see that if you press Ctrl and click, it's just going to basically do a similar thing, just with a different subject, a default body of the email of the feature that you want to request for the add-on. Alright, so that's the first thing. To start with, I'm going to showcase the Beveler function, which is probably the most interesting function currently of Magnolia. In this case, I have two simple shapes, a cube and a cylinder. The cylinder has a bronze material and the cube doesn't have any material currently. So you can select any amount of objects that you want, Ctrl W, and Beveler. In the case of objects without material, it is going to automatically create a metal material so you can see the bevel better. Once you are on this mode, you will see these lines coming out, which indicate the amount of bevel per vertex. In this case, if you run the Beveler function from object mode, it's going to apply it to all the vertices on the mesh. However, as you can see, we cannot really see the Beveler taking place currently, and this is because the Beveler function uses the bevel shader, which is only available on cycles to preview. So for that, we have this shortcut inside the model, which is toggle render. So we press B, and when you press B, it's going to switch to cycles. All right. So here you can see the current bevel value. You need to move the mouse from left to right to either augment or diminish the value. Okay, but let's take a little step back. Once you click also, you will be taken to the previous rendering mode, even if you switch to render view inside the model. Okay, that's mostly for convenience. So let's focus on the cube currently. Let's bring up the Beveler, press B to move to display mode, and I'm going to teach you how you can navigate the scene inside the mode. You can choose middle click and move the mouse to simply move or rotate around the object. You can press Ctrl, the mouse wheel, and up and down to rotate. And you can also use Shift and the mouse wheel to pan. And to exit the model and apply the changes, just press click. If you bring up the menu and you hover, you will see that we have 3 modes. I'm going to cover 2 of them right now, which is entering the model with Ctrl and with Alt. If you press Ctrl, click Beveler, it's going to automatically go to the render view. If you press Alt click, it's going to switch to render view, but it's going to lock the object, so you cannot modify it. This is mostly to preview the current state of the object. Having said that, to either lock or unlock an object to be edited, you press L. Alright, so now it's unlocked. And of course you have here the help box with all the shortcuts. So you can lock it again if you need to. In the case that the sensitivity of the mouse is too big and you need more precision, you can press Shift, which is going to give you more control over the size of the bevel. Right. Another thing you can do is press Q, which is going to toggle all the overlays. Let me lock it. And let me also disable the transparent fill. Right, so Q, and this is also a better way to visualize your object. Now let's focus on a little bit more complex shape, but still pretty simple, which is this cylinder right here. So we are going to watch a few other options we have here. You can go into edit mode and select any vertices that you want, or edges or faces, and you can go into the beveler, and that is going to only affect the bevel amount of those selected edges. So if I want something more thin here, I can do it so like that. And if I want maybe a bigger bevel here, I can also do it just by selecting those edge rings. And this can also be per vertex, so you can also choose modify the value of one vertex. One thing that you might do is, for example, have an edge ring with something like this, which may look a little bit weird, but in the case you have different weights and you want to normalize or equalize the select vertices to the same value, you can press E, and that is going to bring it to the average weight, and you can move it and adjust it to the length of the bevel you want. So this means, for example, if we have this at a minimum and maybe we have some vertices that are a little bit off, but we want to have the same radius of the bevel, you should press E, and that is going to bring it to the same level. Another thing you can use is the X and Z shortcuts, which is going to reduce and augment the amount of the bevel. So let's talk about the other mode, which is Shift and click. This basically adds a triangulate modifier, and this is mostly in the case you have some artifacts with the beveler, which might happen. Let's see if it happens here. You can see it happening right here. Right? We have this artifact right here because we have a big n-gon here. So shift click beveler, and that's going to add a triangulate modifier that's going to only apply for n-gons. And if we inspect again, you can see that that artifact is gone. So that brings us to our next subject, which is the support for booleans. As you can see, we have a boolean right here, and the vertices of the boolean are going to fall back to the value of the min bevel shown here. You can press B here, and that is going to switch what type of bevel you are modifying. So you can modify the min bevel. This will not update live. You have to press B again to apply it, move it, okay? And that is basically going to clamp the bevel down to that value. This property can also be modified directly from, let me switch to cycle a little bit. You will find this property here on the object level custom properties, and you can modify the min bevel from here too. But of course, the ideal thing might be to apply all the booleans and choose work directly with more control over each vertex. The Beveler also offers some options for baking. So we are going to lock mode, and you can see here that we have some settings right here. A few things, control and mouse wheel will determine the resolution of the texture that you are going to bake the normal map to. Alt and mouse wheel is going to change between either OpenGL or DirectX, and with Shift and mouse wheel you can adjust the margin of the bake. Another thing is that you can do unwrap directly from here if you press Ctrl U. This is not really recommended for final assets. Depending on the complexity of the asset, you might want to do a proper unwrap, but we can do the same here. Choose Beveler, Ctrl U, and it's going to do an unwrap of it. Let's come back here, and let's now do a bake, let's say with a margin of 4 and a resolution of 2K. So Ctrl N is going to start the process of baking the normal. Alright, so the bake has been done, and as you can see, the shader or the material applied to this cube has been updated. So let's see what we have here. Here we have the image preview of the bake that you might want to save, of course, to export either to Soft Painter, Unity, or whatever. And you can see that the image has also been added to the material. The image has the information, which is basically the name of the object, bevel, the bake resolution, and the type of normal map. And you can see that we are on Eevee, or also material preview works, and we can preview our baked bevel. And it's a pretty clean solution. Of course, if you look very closely, you will see some seams, but that is to be expected. Let's now go back into Bevel with Alt to lock it, and we can press P to preview or disable the preview of the bake. And if we see this on the material, you will see that it's basically switching between the shader and the map, essentially. Now let's take a look at some other options of the baker. In the case you have two objects, for example, but you want to bake only one normal map, you can just run this, Ctrl U, it's going to unwrap both objects and pack it on the same UV space. You can press Ctrl N, and that will generate a new bake including both objects in a singular image or normal map. As you can see here, we have some issues. This depends on the margin and the resolution that you choose to bake on. The other thing that you might want, however, is to have a separated bake, basically one map per object. In that case, I have unwrapped the objects again, and now they are by themselves occupying the whole UV space, and we are going to bake them again, but in this case we are going to press S to turn on the feature bake self. Again, bake margin and resolution, Ctrl N, and this is now going to generate two different maps per object selected, essentially. So now here we have the cylinder image, that is this one right here, and we also have the new bake for the cube, which is this one right here. So that really depends on your workflow, if you prefer to bake a multitude of objects into the same map, or you prefer to keep them on separate maps. Let's take a look at some other minor features of the Beveler. I'm going to create a new material, and let's suppose that we have a normal map here. If you run the Beveler, it is going to attach, or basically essentially it's going to keep the previous normal map that was connected while still adding the bevel on top. So you can unwrap this again and do a bake, and there you will have the new map with the previous normal map that was into the normal slot of the material. Okay. And the other thing is that if you are to insert another material into the mix, and you were to run the Beveler again, it is also going to apply to that new material. Okay. So maybe you can select this face if you want, lower the bevel width, and again Ctrl U, Ctrl N, and that is basically the Beveler function of Magnolia. Very useful to make this type of tiny bevels or edge bevels. They really add a lot to your assets, and they avoid you having to fiddle around with trick geometry, this type of bevel. If you want to make them with geometry, it's going to be a little bit rough. You will get into a lot of vertices, into intersections and topology issues and more. And plus, it's also more performant because, of course, you have less vertices on the mesh itself. So it's also easier to modify and to use on real-time projects such as a game, for example. Let's now take a look at the align edge feature. Let's say, for example, that you rotated your object and applied the rotation, and you want now to align it back to a default position. Let's say you want this edge to be parallel to the y-axis. So you can select that edge, go to align edge, and you will see that you will get a plane that you can scroll through. You have 3 planes in this case, and the one you might want for this, you can go to the top view, and in this case we want XY. Now this is going to align this edge and make it parallel to the x-axis, so you can press R and it's going to apply that rotation. However, if you want it aligned to the y-axis, you can press Ctrl and scroll, and that is going to rotate it, in this case on the z-axis, right? So Ctrl and rotate. It can be up and down, and that is basically going to rotate the object 90 degrees. So there we have it aligned to that axis. Now in some more complex cases, it will also work for a single axis at least. Let's say we want this aligned to this z-axis. Again, it's first going to align it to the x-axis here. So you press R and it's now parallel to the x-axis. Control scroll, and we rotate it 90 degrees to be aligned in the z-axis. We can now also go here and choose this. You might, in that case, if you saw, you might need to apply rotation several times, so that is clearly not parallel. You press R again until it is, and then again Control scroll to make it parallel to the other axis. And this basically works with as many objects as you want. So let's randomize the transform of this and apply the rotation. Let's say we want these edges to be parallel to the x-axis. There you go. And now they are. Let's now take a look at the inspect mesh function. Here I have Susan, and we are going to first take a look at some of the analysis function. Now these functions come with Blender by default, but I don't know if many people know about them. You basically go into edit mode, viewport overlays and mesh analysis, and here you will have those options. Okay, this is basically an interface to go through them more easily. So first analysis is the overhang. We have the second one, which in this case is not going to show up. We have the distort, intersect, and thickness. Okay. If you go to the documentation of mesh analysis, you will see that this is mostly aimed at 3D printing, but also some of these options are useful when doing models, or like intersections might help you debug some artifacts with bevels, and distortion might help you identify non-planar faces, right? But let's take a look at some of the other functions that we have here. First one, if you press F, you are going to take a look at the face orientation. So let's say, for example, that these normals are flipped, and of course it's pretty obvious right here, but in case it isn't, if you press F, you will be, of course, be able to see them. In that case, you can choose recalculate the normals again. In this case, we don't have any triangles, but in this cube right now we have 2 triangles clearly, which is this one and this one. So if you come here, you will see a count of the amount of tries and also a count of the amount of n-gons in the mesh. You can press T and that is going to highlight the triangles on the mesh, right? And you can also press N, which is going to highlight the n-gons in the mesh. Now if we go back to Suzanne, we'll see that we have some non-manifold faces. So you can press Y, and that is going to highlight those faces. For more clear on what this implies, we are going to create an interior face here, and we're going to inspect the mesh again, and now we see that we have a non-manifold face. We can highlight, and that is going to clearly show us where that face is. And this also works for edges. So if you were to have, for example, a hole here, or if you were to have something like this, or some vertices for some reason out there, or a whole edge disconnected, this all is going to show up here on the count. And also if you press Y, you will be able to see them clearly. So here you have the vertices and the edges, as well as the faces. Another thing that might come up and might cause some troubles is when the orientation or the pivot of an object is not aligned properly. It really depends on the situation, but in some cases it might cause you some trouble. I'm going to press P, and this is going to give me a preview of the orientation of the pivot. So the thick lines are the orientation of the pivot of the object selected, and the thin lines that fade out are a reference for the global orientations. So if you see that your orientation is not correct on your pivot, you can reset it. So a few other things that we have, you can press 1 and that will give you the information of the vertex normals. You can press X and set to increase or decrease the length of the normals. You can also press 2, and that is going to give you the split normals of the vertices. You can press 3, and that is going to give you the edge lengths, the angles, the areas of each face, the angles of the faces, and the normals of the faces. And the keep alive function, basically if you control click, it's going to stay in edit mode instead of going back to object mode. And that's basically the mesh analysis or mesh inspector tool. Let's now take a look at the export at origin feature. For this demo, I'm going to use the brass band model by Rico Cilliers and the ukulele model by Joseph Bergen. Okay, so I have them imported into Blender, and they have a pretty standard PBR setup, other than the metallic and roughnecks are into the same map. But other than that, pretty standard PBR. One of the common issues when exporting to a game engine is that if your model doesn't have the origin at the center, it will basically mess up the origin when you import it. So yeah, it might cause some issues. So you can select as many objects as you want, and in this case we are going to start by exporting FBX format to both Unreal and Unity. By default it will export at Unity as an OBJ. In this case, if we want to export at Unity as an FBX, we just press Alt click. Okay. Now you can create a folder for your export, and you can simply click or put the name to your models, and export FEX. As you see, the models have been positioned at the center. You should scan Ctrl-Z if you want them back at their original position. Now you can go back to Unity and import new assets, and we are going to go to this folder where we are going to find the FEX and a folder. We are first going to import the FEX, which includes both our models as well as the materials. On the folder we have the maps of the materials that were exported with the tool. Okay, so you can import this. You fix the random maps, and as you can see, they have been automatically applied by Unity to the materials. Now in this case, because the shaders are different and we have a pretty particular setup here with the metallic and roughness into the same map, but different channels of the map, it's not going to apply or translate to the Unity shader. So you will have to set that up manually. So you can go to extract materials basically, and you can, set them up here. But if you import the models into the scene, you will notice that something is not right. So here on Blender, we have the handle of the pan pointing at the positive Y direction. Here on Unity, however, forwards is set, and as you can see, the pan is rotated 180 degrees. So you can see here minus 180. To fix that, you simply go to the FEX model, you check Bake Axis Conversion and apply. And now they are correct. Okay. Let's now check out the case of exporting an FEX for Unreal. Pretty much the same thing, but you see that you have to press Ctrl to export for Unreal Engine. If you want a FEX and to export to Unreal Engine, you will have to press Ctrl Alt click. Okay, same thing. Let's create a new folder here for the Unreal. So now we can import the model to Unreal Engine. You might want to import it with a rotation of 180 degrees on the Z-axis, again to make it forward. So the forward of Blender is essentially the same as the forward in Unreal. So import all. And Unreal will also automatically import the maps and texture and set up the material automatically, so you don't have to worry about manually importing the maps. Okay, so as you can see, there we have them. Let's now try exporting the obj files. Pretty much same thing. Only thing different basically is that you cannot export the texture maps when exporting an obj. So this is the obj for Unity. Let's import that real quick. The obj has the forward direction properly, so you don't have to make axis conversion. It still extracts the materials properly, so you can set them up manually. And obj support is not available for Unreal, for Magnolia. But in any case, I suggest that you use FEX over obj, as it takes the materials and the maps with it. Let's take a look at the display non-planar feature of Magnolia. For this feature, you will need at least Blender 3.2, as it uses some geometry nodes that were released with 3.2. you should select the objects that you want to apply to, and you will have a geometry node right here. Now what this does is apply a material to the faces that are non-planar. It is really essential to detect non-planar faces, especially if you are doing hard surface modeling, as it might introduce some issues with shading. So, as you might guess, the non-planar faces are the ones that are highlighted in red. So you can make use of the Loop Tools Flatten add-on. In this case, I want to flatten these two, and just click Shift R after that to be able to repeat the flatten operator. So you should select the red until it's gone, essentially. Now the threshold of what is considered non-planar in this case is very low, so you may want to increase it a bit, let's say to 0.02 or so, and that is going to be a little bit more forgiving. Okay, so we have this, we kind of want that there, so we flatten, and yes, that's basically it. We can go into the geonodes and you will see that the setup is pretty simple. This detects if a face is planar or not, and if it is not planar based on the threshold, it's going to apply that red material. Okay, and that is basically the feature. Let's now look at the snapper function. So again, you have different modes. You can press Shift if you want 0.5 increment, and what this does is basically snap the vertices of an object to that increment. Okay, and this can be very useful if you are, for example, blocking out a level for a game and you want to test it inside of Blender, or if you are also blocking something like a model, it can be also really useful. And you can just play around with it, really. And of course, this is a geometry node, so it's non-destructive. You can put the increment to a very low number, and that is has basically no change at all. But let's keep it at half a unit for now. So let's say now that you make a floor here, and maybe a wall. You can now, for example, go into view navigation. You can press, I think it's Alt to toggle gravity, and now you can basically navigate through the level as if you were into a first-person shooter. Okay, so this is useful to basically block out levels. And now let's say you want to get more precise. You can maybe add a cube here. Okay, let's apply scale. And let's add a snapper with a lower increment, in this case Alt. And again, just come here. Another thing is that in the case you were to have, for example, a cylinder inside a mesh with a very big increment, you might want to ignore those vertices. For that, you can create a vertex group, for example. You can name it whatever you want. You assign those edges or vertices, sorry, and you click this button right here on the snapper, and then you go here and select that vertex group, and that is going to ignore those vertices essentially. Again, the node setup of this is pretty simple. It's basically takes the position and it uses the snap math function for vectors for the position of the vertices, and at the end of it, it also does merge by distance, so you make sure you don't have any double vertices in a single place. Let's now look at the mesh name to object name. It's pretty self-explanatory, I guess. And as you see, the mesh name doesn't correspond to the name of the object. And this can be a bit of a pain, especially if you are exporting to another software, because the name of the mesh might be appended to the name of the object itself, and it can get confusing. So select all the objects you want and choose click it, and that is going to do what it says basically. These are link duplicates. As you can see, they are sharing the same mesh, and it's basically going to set the name to the last selected one. Let's now take a look at non-uniform to collection. I have right now all of the objects in my scene with non-uniform scale, and that is not something that you generally want. So let's say we select some objects, we click that, and it's going to generate this collection. It is not moving the objects from other collections to this collection, but it is assigning them. So as you can see, you can have multiple objects on different collections or multiple collections. So what you can do is have these objects, select them there, and in this particular case, these trees are multi-user meshes. So as you can know, you cannot apply the scale of these objects without creating a new mesh. So in this case, if you go to non-uniform to collection and you press Ctrl click to apply a scale, you will see here that it is going to skip applying the scale to those objects. And you will also see that those objects that previously had non-uniform scale have been applied the scale to and removed from the collection. So now we can go again, click here. It's going to take all of the objects with non-uniform scale. We can again select all of them, Ctrl click, and it's going to apply the scale to those objects. So now they are all good. We can check with inspect mesh if any of them got any issues with the normals, which you might get when you apply the scale, but in this case, no issues at all. You can remove these objects from this collection if you want. Once the collection is empty, it will remove itself from life and existence. Now there might be a case where you mistakenly maybe have the collection selected and you created a plane or any other object with proper scale, uniform scale, and you happen to Ctrl click. In that case, it's going to delete the collection if there are no items with non-uniform scale in it, and it's going to remove the uniform scale object and it's going to assign it to the scene collection. Okay, so no objects are lost in the process. So the last feature that is currently available with this first release of Magnolia is one that you will probably not use unless on very specific circumstances, and that is stack UV faces to cursor. So as you can see here, I have a wood palette that is not unwrapped. So I'm just going to do a quick dirty smart UV project. And it's showing this texture atlas. So I've been working on a PS1 style game, and so seams and stuff like that don't really matter that much, but I really found myself without any feature either on UV Packmaster or text tools or other to align all selected faces to a specific place in the UV map. There is the setting to align similar faces, but that is not what I'm looking for. So in this case, what this is going to do is literally take all the selected faces and align them into the cursor. So you can shift click on the UV map to place the 2D cursor, and Ctrl W to bring the Magnolia menu for UVs and stack UVs to cursor. Okay, and that took all the faces and did what it's supposed to do, which is align them there to the position of the cursor. And as you can see, very quickly. I've been doing this manually, and this tool saved me a lot of time. I basically made it for this project alone. So if you happen to be working on a PS1 style of game or something that might for some reason require this feature, hopefully it will save you some time. And that is basically it for this demo or tutorial of Magnolia. Again, this is the first release. More features are planned and bugs are probably there. So please, if you have any feature suggestions or bug reports to do so I can improve the product, just use your convenient report bug button here, or just contact me directly through email or somewhere else. If you think it's worth it for you, please take a look at the links in the description. You can currently get it at Cambrad and Blender Market, and hopefully it will save you and make your life easier in Blender a little bit. Hope you have a nice day, and I will see you in the next video.